thank you to Provost Burke for being here. Thank you to the ILP, I see Dean Monroe, Dr. Heifers here, and I know there's a couple of other deans along the way. And then I'd also like to introduce our judges. Dean Ekman, our Dean of Libraries, Grow, Chair of the Department of English, Dr. John Bixby, our Vice Provost for Research, and I almost said Dean Filatinsky. Also Dr. Filatinsky, our Vice Provost for Institutional Culture. Also, very special welcome, not only to our competitors, but to their faculty advisors, to their family, their friends, their fan club. Thank you all for being here. And finally, I'd like to thank the Digital Media Lab at the library, the Topple Center, and the Writing Center, who have offered their support and have offered this competitive support. And with that said, I'm going to turn it over to Tatiana Perino. Oh, there she is, the Dean.
Hello, everybody, and welcome. My job is just to tell you a little bit about the rules. The competitors are very familiar with them. In a nutshell, they have a single PowerPoint slide to present. No animations, no props, no costumes, no additional electronic media. Their presentations are limited to just 3 minutes. There's a clock here on the side. Once it beeps, they have to stop. I've told them that it's very important to stay within 3 minutes because otherwise they get disqualified and that would break our hearts. And those are basically the rules. For the audience, it takes a lot of concentration for these folks to get their whole thesis into 3 minutes, and so distractions can be kind of tough. So if you could take a few minutes just to check that your cell phones are turned off, and if you can, just keep the noises and distractions to a minimum. We will encourage you to go out and in between the talks. You only have to wait 3 minutes. So hopefully this way our folks can say, well, thank you very much for being here.
Hi everyone, I'm Becky, I'm the president of the Graduate Student Association. I just wanted to introduce this competition as part of our graduate research day. Earlier today we had our first inaugural Research Intersection Symposium. A lot of really good interdisciplinary conversations came from that. We had 8 panels over the course of the day, and a poster session featuring 20 to 30 graduate students. It was really exceptional, and at the end of this event, we will be presenting awards to students from that symposium as well. We're really excited to continue the collaboration between the Graduate Student Association and the Graduate School in making sure that work from all over the university is highlighted and showcasing the best our students have to offer.
Okay, so with that, we are going to begin the competition. Our first competitor is Philip Stodable. He is a PhD student in marine geosciences at the Rosenstiel School of Marine and Atmospheric Science. The title of his dissertation is Application of Pumped Isotopes in the Study of Marine Diagenesis. His advisor is Dr. Peter Swart.
The picture behind me is of the La Jolla Cliffs in my hometown of San Diego, California. The sand that these cliffs were made of was deposited millions of years ago as beaches and as offshore deposits. And they're now high and dry, but it's obvious that something happened between then and now. The sand turned to sandstone. So how does this happen? How does sand flowing in water or blowing in the wind go and become a material so hard that you can build, in this case, a school right on the edge of a cliff? The answer is glue. After sediments are laid down, chemical processes occur which form minerals that act as a natural cement, which binds the sand grains together. That happened to these cliffs, and it also happened here in Miami to form the Miami oolite, the limestone bedrock on which all of our houses are built. Remember that the wise man builds his house on stone, not on sand. So the focus of my dissertation is on studying the processes by which these chemical cements form, and with a particular focus on the temperature at which the cementation process occurs. So how do I do this? How do I calculate the temperature? By analyzing a mineral. In this case, I studied calcium carbonate, which is the most abundant marine cement that I studied. And what I do is I study the chemistry of these minerals. So calcium carbonate contains the carbonate ion, in which 3 oxygen atoms are bound to a single carbon atom. Carbon and oxygen come in different types, called isotopes, which are differentiated by their mass. Heavier isotopes form stronger bonds to one another, and so there's a tendency for the heavier isotopes to clump to one another. And because of this tendency, there's more of these clumped isotope bonds within a mineral than you would expect in a random distribution. At higher temperatures, however, this system tends towards disorder, and there are fewer of these clumped isotope bonds. So if I can study the mineral using a device called a mass spectrometer, I can count the number of these bonds and then calculate the temperature at which the mineral formed. I've applied this technique to study sediments in the Bahamas and in Antarctica, where I studied long sediment cores, each nearly a mile long, which record the transition from loose sediment at the top to a well-cemented sandstone at the bottom. And what I find is that when I chemically analyze the cements at the top, you calculate the cold temperatures you would expect at the bottom of the ocean. But as sediments are buried more deeply, you start to record these warmer and warmer burial temperatures because of the heat of the earth. From this, we learned that the cementation process doesn't happen at one particular time or depth. Rather, it's an ongoing process that continues to occur as sediments are buried more deeply. While conducting this research, my colleagues and I worked to develop a technique that can be applied to a number of other geologic questions. And now there's a new generation of graduate students who are beginning their research, continuing my work, as well as developing unique projects of their own. I look forward to seeing where their projects take them and hope to participate in this research in the future. Thank you for your time.
After each competitor, we're going to give the judges a minute or so just to make some notes. Okay, our next competitor is Carter Morgan. Carter is a PhD student in business with a concentration in marketing. The title of his dissertation is After the Nudge, Exploring How Defaults Affect Consumers After the Choice. His advisor is Dr. Claudia Thompson.
Good evening, everyone. Over the past decade, there's been an explosion of research in choice architecture, or the subtle and deliberate use of variations in the decision context in order to influence or nudge people to make certain decisions that align with policymakers and marketers' goals. Now, one of the most popular ways to nudge decision makers, and the focus of my research, is through the use of defaults. A default is a pre-selected option that people automatically receive unless they explicitly choose otherwise. Now, one example where defaults have been used popularly is in organ donation. In the United States, by default, people are not organ donors. However, in many European countries, by default, people are organ donors. This subtle difference in the way in which a choice is presented has been estimated to account for over 6 million more organ donors across these European countries as compared to in the United States. Now, a lot of this research to date on defaults has really only examined this initial choice. And what they haven't considered is how accepting or overriding a default option when making a decision might influence the way people think in other ways. But this is interesting because prior research shows us that the choices we make can actually influence the way we think about ourselves. And this is important because the way we think about ourselves can actually guide our behavior over time. So when I make the choice to be an organ donor, for example, that choice tells me that I'm a compassionate person. And by seeing myself as a compassionate person, I'm more likely to help others in the future. So if we know that the choices we make influence the way we see ourselves, and defaults influence how we go about making decisions, then might accepting versus overriding a default option change the way we see ourselves and thus behave over time? This is the aim of my research. In particular, I suggest, my research tries to answer this question. In particular, I suggest that overriding a default in order to select an option will actually significantly change how people see themselves. So when Americans override the default policy in order to become an organ donor, they should see this decision as a more active endorsement of their chosen option. As a result, they should consider themselves to be more compassionate and thus be more likely to help others, even compared to if they didn't have a default policy to begin with. Now, my research has expanded this default override effect to other decision contexts, showing that people can actually be influenced by this effect in the products that they purchase. And so together, my research helps to expand our understanding of defaults and perhaps even nudges more generally, showing that the way in which we make decisions not only influences our decision making, but can even change the decision maker. Thank you.
The next competitor is Julian Grijaldo. He is a DMA student in composition in the Frost School of Music. The title of his dissertation is At the Edge of Hope, a cantata for the everyday Colombian. His advisor is Dr. Dorothy Hyman.
Since I moved to the US from my native Colombia, I have become aware of the difference between what the international media displays and the reality Colombian citizens live in. The feature news is mostly about the peace treaty with the FARC guerrillas and the now called post-conflict period. In other words, how we all lived happily ever after. Colombian citizens, however, still deal with rampant political corruption, violence, and a pronounced social inequity. Adding grief to injury, the victims of the armed conflict have received little to no restitution for their losses. As a Colombian music composer, I decided to address this problematic by creating a work that would bring attention to their untold stories. I went back to Colombia and visited the 5 mainland geographic regions: Caribbean, Pacific, Andean, Amazonian, and the East Plains, and collected the testimonials of 30 citizens affected by violence. I heard their stories and asked them what they thought about the peace treaty. These people had suffered the effects of forced displacement, extortion, kidnapping, among other things. Yet, amidst their stories, I felt their unwavering hope to get a better country. One of the most shocking stories that I heard was about a 7-year-old kid going back to school several months after his parents were killed in front of his eyes. They even, the group that did this, dared to tell him they would let him live as a cautionary tale. His teacher would struggle trying to explain to him why it was not a good idea to tell his classmates this story. He thought this was normal. With these stories, I composed a large-scale vocal work entitled At the Edge of Hope, a cantata for the everyday Colombian, for soprano, baritone, choir, and accompaniment. I commissioned 3 Colombian poets to write the lyrics based on the stories that I collected. And additionally, I incorporated different elements from popular and folk music from the 5 mainland regions. I had a previous knowledge in this field. However, my field research allowed me to go a step further. I studied for the first time Amazonian music and African Colombian music from the Pacific coast. At the Edge of Hope doesn't show a unified narrative that addresses or celebrates a peace treaty. Instead, it shows a multiplicity of narratives of different citizens who have lived through the conflict and their perspectives on peace and forgiveness. Thank you very much.
Bishop. Kiman is a PhD student in cancer biology at the Miller School of Medicine. The title of her dissertation is The Role of LDH in Promoting Basal-like Breast Cancer. Her advisor is Dr. Caroline Riegel.
Good evening. I hail from California, a state that is extremely vulnerable to fire. 19th century writer Leigh Hunt described fire as the most tangible of all visible mysteries, and I happen to agree. While the flicker of a flame is mesmerizing, at the same time, its destructive potential is terrifying. And while fire in moderation can be a good thing in nourishing soil and replenishing natural habitats, when fire grows and burns uncontrollably, a wildfire is born, and wildfires are capable of destroying everything in their path. The same can be said for the growth and division of the cells in our bodies. While normal cell growth and division would result in a human being like you and I, when that process is dysregulated, we're dealing with cancer. So if normal cell growth and division can be likened to a fire, then cancer is a wildfire. Before wildfires grow too large, they can be stopped. This usually involves multiple methods, such as isolating the fire from fuel or dumping water or chemicals on the blaze. In the same way, we can treat early-stage breast cancer by targeting treatable proteins in cancer cells that play crucial roles in the progression of the disease. But one type of breast cancer in particular, triple-negative breast cancer, loses expression of those treatable proteins as it very quickly advances from a small, unnoticeable spark to a large, uncontrollable wildfire. Because it loses expression of those proteins, there is no consistently effective treatment for this type of breast cancer. So similar to the way that we dump water and chemicals on a large blaze in an attempt to contain it, we assemble various drug and treatment combinations to treat triple-negative breast cancer in hopes of curing it. Sometimes we are successful, but hundreds of thousands of women stand to benefit from improved treatment options. So what if we could identify fire-prone areas before they set alight? Better yet, what if we could identify crucial events in the progression from fire to wildfire? That is the focus of my dissertation project. We study a gene, LBH, that identifies cells undergoing key genetic changes in the progression from a normal cell to a cancer cell. And while we knew from previous work that LBH is overexpressed in triple-negative breast cancer relative to other breast cancer types in normal tissue, my work has shown that by depleting LBH, we trigger changes in aggressive triple-negative breast tumors, including the re-expression of treatable proteins. So the major implication of our work is that we could potentially resensitize breast tumors to existing and effective treatments. We could make a wildfire more vulnerable to water. Thank you.
The next competitor is Haley Mathis. Haley is a PhD student in philosophy in the College of Arts and Sciences. The title of her dissertation is Care Ethics, Morality Without Responsibility. Her advisor's name is Dr. Michael Sloat.
So here's a question. Do you have free will? I think a lot of us want to say yes, obviously I freely choose to do things all the time. But philosophers and scientists provide significant challenges to this assumption. How can you be free given that you're also strongly influenced by your early childhood and your genetic makeup? And new worries about free will keep emerging. In recent studies, neuroscientists found that they can predict a person's movement by looking at which parts of their brain lit up. So scientists could predict movement even before a person was consciously aware of even making a decision to move. So how can that decision be free? This is just a drop in the bucket of challenges facing free will. What I want to know is, what does this mean for morality? Can we fairly blame the murderer if it turns out they're never acting of their own free will? Can I fairly praise my sister when she donates her spare time to helping children in need? It might not be her free decision to do this after all. Why tell me what I morally ought to do if I'm not free to then go do it? In other words, can we even make sense of morality, praise, and blame if it turns out we don't have free will? This is the challenge I combat in my dissertation. I think we still need to be able to understand morality regardless of how we answer this question about free will. The challenges that are facing free will just shouldn't also be challenges facing morality. As such, we need a moral theory. Philosophers need to give us a moral theory of what makes an action right or wrong. that doesn't rely on a theoretical assumption about free will. I think a moral theory called care ethics is the answer here. Care ethics explains morality in terms of empathically caring relations between people. This is quite different from theories that understand morality in terms of a set of rigid rules you must choose to then go follow. Care ethics says that what makes an action right is that it displays empathy and care. I think this emphasis on emotions and our relationality allows it to explain what makes actions right or wrong without relying on assumptions about free will. So when I see my sister caring for a child in need, care ethicist explains why it's perfectly permissible to react with positive praising emotions of her. It warms my heart to see her care for others. It's as simple as that. The question of whether she's freely choosing this is beside the point. Likewise, if I see a murderer display malice and hatred towards another person, as a caring person, I'm going to respond with shock and pain. To ask whether my shock and pain is rationally justified given some theoretical assumption about free will is to over-intellectualize morality. Notice too, empathy and care are direct and immediate motivating forces. When you empathize or when you care for somebody, you're motivated to act. And the question of whether you're freely choosing to do this, it just doesn't matter. Understanding morality in terms of empathy and care means that our moral standards are not in danger even if the concept of free will is. Thank you.
The next competitor is Summer DeBastiani. Summer is a PhD student in nursing in the School of Nursing and Health Studies. The title of her dissertation is A Population-Based Assessment of Suicide Risk. Her advisor is Dr. Ann Norris.
My home is located in the beautiful Florida Keys, about 80 miles north of Key West, and many people consider my home to be paradise. After all, the Keys is the land of boating, fishing, or a fun night out on world-famous Duval Street. But there is a dark side to the Keys. We have some of the highest skin cancer rates in the state, and the use of alcohol and other illegal substances are also some of the highest in the state. Many Keys residents struggle to access health care, and we have some of the highest costs of living in the nation. Some of these problems may not be surprising, given the Keys' reputation for fun in the sun. But one problem that surprised me is that we also have some of the highest suicide rates in the state. I wanted to know why so many people were choosing to kill themselves in an area of the country that many people consider to be paradise. I decided to dedicate my dissertation research to helping the Florida Department of Health and Monroe County understand what factors might be contributing to suicide risk in my community. Through my collaboration with the health department, I added questions asking about suicidal behavior and suicidal thoughts to the 2016 Behavior Risk Factor Surveillance Survey, a survey that collects data that's generalizable at the county level every 3 years. So this means my results can be used to talk about everybody in Monroe County. I found that suicide risk in Monroe County is 3% higher than statewide estimates. 3% might not sound like a large difference, but it translates to hundreds of lives. I also found things we already know about suicide risk, such as those with depression or worsening physical or mental health conditions, are at higher risk of suicide in my community. These findings were not surprising. But one thing that surprised me is that those at risk for suicide in Monroe County were more likely to be renting their home as compared to owning their home. However, when I think about life in the Keys, this finding makes sense in a scary sort of way. Comparable to the high suicide risk, we also have some of the highest percentage of renters in the rest of Florida. Additionally, about 20% of our households pay more than 50% of their income for housing. Hence, an important implication of my research is that if we want to do something about suicide risk in Paradise, then we need to do something about affordable housing in the Keys. Unfortunately, our housing situation has only gotten worse since Hurricane Irma, which destroyed 25% of our homes in our community, particularly our low-income housing. Suicide is tragic, but it is preventable. If you have an opportunity to advocate for affordable housing in the Keys, please do it. If you know someone who is struggling with these issues, help is available. Take action. We must all play a part in prevention. Thank you.
The next competitor is Belen Fadrique. She is a PhD student in biology in the College of Arts and Sciences, and the title of her dissertation is Forest Dynamics in the Andes-Amazon Region, Distribution of Native Woody Bamboo and its Effect on Ecology and Physiology. Her advisor is Dr. Enid Feely.
Even if you've never been to the Amazon, you probably know a lot about it, right? You know about the huge trees, the high diversity, the problems with deforestation or climate change, but you probably don't know that there is an area as big as Florida, naturally covered in 70 feet tall bamboo. And that's normal, not many people know about this, mainly because there is a lack of bamboo research in this area, and also because there are not cute panda bears in the Amazon. So, bamboos are the biggest grasses on earth. They grow really fast and they're strong competitors. Most bamboo species only flower once in a lifetime, and then the whole population dies. So in the Amazon, every 30 years, big bamboo populations of the size of Miami flower and then die at the same time. So that is a huge disturbance for the forest. Because of its abundance, aggressiveness, and disruptive life cycle, bamboo can have a very important impact on forests. So in my dissertation, I studied this topic in Peru, in an area, an elevation gradient from the Amazon to the high Andes. So first I studied the effect of bamboo on Andean ecosystems. I counted and measured over 20,000 bamboo stems in 10 study plots where we have historic tree data. My results show that bamboo is the most abundant plant group in the area, and where it occurs, the forest has an altered structure with fewer and smaller trees than bamboo-free forest. Next, I wanted to know if bamboo affects the health of the trees. So for that, I used over 600 satellite images of the Amazon, such as the one on that image, from 1984 until 2016. And then my results show that Amazon trees do not like having bamboo around. They suffer continuous stress because of the strong competition with bamboo for water. And then they show a huge relief when bamboo dies every 30 years. So after determining that bamboo affects the structure and the function of the forest, I tested for the climatic tolerances of the bamboo species growing in the area. And I discovered that bamboo is actually well capable of coping with the combined stress of higher temperatures and lower precipitation, which are the conditions predicted for the area. So this persistence of bamboo in the Amazon forest and the Andean forest can have a very important effect on the composition of this forest. So we know that the Andes and the Amazon are among the most important ecosystems on Earth. And in my dissertation, I have found that bamboo affects the structure, the composition, and the functioning of the forest on these regions. So researching the interaction between bamboo and forest is crucial for management and conservation of these areas. So even without the pandas, we just cannot ignore bamboo anymore. Thanks. Is Alvaro Ruiz Esperanza. He is a PhD student in civil engineering in the College of Engineering, and the title of his dissertation is Durability of GFRP Rebars Under Aggressive Environments. His advisor is Dr. Francisco de Caso y Barceló.
Good afternoon, everybody. My name is Alvaro Ruiz, and even if I see you all very relaxed, I actually came here to warn you that we are suffering a great problem. So what's happening? Our infrastructure is getting deteriorated vastly. Our bridge and roads are mainly made of steel reinforced concrete. It's a combination of concrete and steel reinforcement. What happens is that with the time, this steel gets corroded, losing its properties and getting the whole structure to be deteriorated. So please raise your hand, whoever has suffered traffic delays here. I guess almost all of you, right? So one of the main reasons for that is actually these repairs that are caused by this deterioration. And actually, the US government spends over $22 billion per year on these repairs. Isn't that crazy? So that's why there are a lot of research groups all around the world who focus on trying to develop more efficient repair techniques. However, at the EU, as always, we go one step further. So what we do is we just directly take the problem out of the equation. How do we do it? So we use alternative materials to steel, which are composite materials, FRPs, fiber reinforced polymers. By using them in combination with concrete, we'll be able to double the lifespan of our structures to over 100 plus years. So the focus of my dissertation is actually to prove this assumption. So how can I do it? Because I cannot be 100 years testing materials. I want to graduate at some point. So what I do is I use what we call the time chambers that we have in the lab, where we create very aggressive conditions by adding different solution at very high temperature, and then we test the physiomechanical properties of these materials and check the resiliency of these materials. But what is more important, we afterwards, through complex mathematical models, such as a reduced relationship, we relate these short-term, can be 1-2 years, results to the performance, the long-term performance of this material in normal conditions. And by now, the preliminary results say that they are really promising. So, if you want that the US government spends all those billions of dollars in other applications as health or education, or maybe Miami, but it's more important, if you don't want to get stuck in traffic, just keep an eye on this technology because it's going to be the revolution of civil engineering. Thank you so much.
The next competitor is Narciso Quigley Rodriguez. He is a PhD student in nursing in the School of Nursing and Health Studies. The title of his dissertation is Sexual Decision-Making Among Men Who Identify as Bears. His advisor is Dr. Joseph DeSantis.
Good evening, and thank you all for coming to this wonderful event. For the next 3 minutes, we're going to be talking about sex. While gay and bisexual men account for approximately 2% of the entire population in the United States, these men account for roughly 67% of all new HIV diagnoses, which is a huge disproportionate number and a huge health burden on gay and bisexual men. Now, there are many different subcultures within the gay community. One of these subcultures is known as the bear subculture, just like the animal. This subculture accounts for approximately 14 to 22% of the gay community. Previous research indicates that research among this group, these men are more likely to engage in riskier sexual behaviors, such as unprotected anal sex, more so than other gay men. However, none of the research has explored why do these men engage in more unprotected anal sex. And that's where I stepped in. I went ahead and conducted 25 one-on-one interviews with men who associated with the bear subculture to understand the process that these men underwent as they made sexual decisions. I explored how do these men find sexual partners? How do these men negotiate with one another? And how do they determine what sexual acts that they would engage in? And I also looked at how do these men reflect upon the consequences of the sexual decisions that they made. In addition, my research highlighted certain factors such as age and relationship status and perceptions of HIV risk that influence these men's sexual decisions. I want to talk a little bit about the HIV risk perception. Many of my participants had lived through the AIDS epidemic of the 80s and 90s, and many of them discussed witnessing friends and family members die because of AIDS-related complications. And during that time, these men were terrified to engage in any sexual activity because they were afraid that they would contract HIV. Fast forward to now, these men are engaging in riskier behaviors because they no longer fear catching HIV. They think that if they go ahead and contract HIV, all they have to do is take a pill a day and they're going to stay healthy. This research is significant because we can utilize the information from my dissertation to go ahead and create an HIV prevention intervention
that can be used to and target this highly susceptible group and lower the odds of contracting HIV. Thank you.
The final competitor is Andrea Peters. She's a PhD student in industrial engineering in the College of Engineering. The title of her dissertation is Finding Efficiencies in Personal Power Autonomy through the Development and Implementation of the Total Scavenging System Concept. Her advisor is Dr. Shihab Osborne.
Let's start by taking a poll. How many of you have ever run out of power on your phones, laptops, or any other device? Same here. As our world becomes more and more digitized, our need for electrical power increases exponentially, thus making humanity slaves to the electrical grid. The pictures to my right, your left, show our reality as of today. The picture at the top left shows you a power plant in Georgia. Pretty at night, right? The one right next to it is of a power plant in West Virginia. And yes, those are high school football players practicing with coal plumes directly behind them. Power is created in plants like these, via coal, natural gas, or some other means. That power is then converted and pushed through our power lines to high transmission towers and pushed to our homes, organizations, and other facilities to power the devices that we so love and cherish. To put the world's power dilemma into perspective, the World Health Organization and the Lancet Commission accounts for over 6.5 million premature deaths per year due to power production. 1.7 million of those are children. That's 3 in 10, but our power demand continues to rise. Thus, the focus of my PhD research is to find the efficiencies in personal power autonomy through my concept of the total scavenging system. Energy harvesting is not a new concept, but the fusion of harvesting is. My system would take current technologies and integrate these to provide individual power and break the necessity of always needing to plug in. My concept will bring in piezoelectric, triboelectric, kinetic, and solar means. What does that mean? Specifically, we all expend energy with every activity that we do, but that energy is never reclaimed. The total scavenging system will reclaim this energy, push that energy to local devices, store the remaining energy, and possibly plug some of that energy back into the grid, thus creating freedom for us to move autonomously. If you want to go out into the wilderness for a week, you can do that. You don't have to worry about being connected to the power grid. What does this system do? It builds in redundancy. Right now, with our systems that we have for harvesting, we don't have redundancy. Therefore, when you plug in these devices, they don't last long. Thus, the total scavenging system brings in multiple technologies in order to maintain your power for a long time. Thank you very much.